Hey, welcome to the podcast. My name is Eric Ortina. I'm your host. I have been a competitive long-range shooter for over a decade now, but I'm still in learning mode. That's the reason that I started this podcast, because I want to talk to people that I can pick their brains and learn something from. Now, why did I call it Believe the Target? Well, the target is really the only one that tells the truth. There's many ideas, many theories, many experts. However, the target ultimately decides who's right. If you're not subscribed to this podcast, make sure you subscribe right now. Go give it a like, and let's get started. Tim, how you doing, man?
Doing good, Eric. Good to see you.
Thanks for coming.
Thank you. You're welcome.
So tell us who you are, what you do, and...
Well, my name is Tim Sellars. I own a company called Sellars Ballistic Technologies. I've done research for around 20 years on rifle accuracy, internal ballistics mainly, and intermediate ballistics. Which is the ballistics within the pressure bubble of the muzzle blast. And essentially, tuners started a lot of this with the barrel vibration stuff, and I was able to progress through tuners into fixed weighting systems, suppressing systems, different type of muzzle control mechanisms, and pretty much just experimented with everything you can imagine. I can make my own stuff. I own my own machine shop, so I'm able to machine any type of device I need for the muzzle. And many years ago, I shot 1,000-yard bench rest for about 15 years, roughly. Mm-hmm. And a lot of the problems we had was the barrel harmonics. And it turns out that the harmonics of the barrels always thought to be minimal. And in reality, even with the thick barrels, it is a major factor in long range, at least 800 to 1,000 yards. And so we always had this problem. Everybody's wanting to shoot the magical 1-inch group at 1,000.
Right. And
what I found over the years, talking to the best, Bruce Baird, Dave Tooley, Bill Shahane, Speedy, of course, all the guys said you need to get your velocities level to do good. Mm-hmm. And that's a tough deal. As far as more than 10 shots, good luck on having a single-digit ES. And it kind of seemed like your groups were basically the sum of your velocity variance. And it just seemed almost impossible to get level enough velocities, mathematically speaking, to be able to do that magical 1-inch group.
Okay.
So many years ago, I was talking on the internet to a forum, and an Australian guy says, well, do you not use barrel vibrations to correct your velocity variance? Well, I've never heard of that. This is around 20 years ago. Mm-hmm. I wish I could remember the gentleman's name. He said, well, we Aussies been doing it forever. Where you guys been? So this is where positive compensation came in, and I believe, I could be wrong on this, but I believe it was originally termed by Al Harrell, Varmint Al. Okay. And at the time I was trying to research this stuff, he was just starting to model actions mainly. The stress pressures on the lugs and so forth, and some people had asked him, well, hey, can you model the barrel, and how does the rifle as a complete dynamic bend? And at the same time, I was doing testing, trying to basically get a slower bullet to hit higher at 100 yards. Tried for years and never could do it. Tried and tried and tried, but what I could do with tuners to make a slower bullet that was hitting lower hit at the same height at 100 yards. Okay, so if you can get a bullet of different velocity to hit the same height, that is positive compensation. Very small, mm-hmm. But it is aiming that slower bullet about a third of a bullet higher at 100 yards. It's hard to see. You really can't define that as an effect that repeats. And every now and then you'd get one that would go high if it was slower. And I got all excited and shoot the next one, and oh man, it would go back down. So that's where essentially the journey started for me with tuners. And what I found as far as setting a tuner defining the function of a tuner, a lot of bench rest shooters many years ago asked me to try to figure out exactly what a tuner does. So as a result of that, roughly 7 years of research on one tuner, 3 barrels, 5,036 rounds, I was able to gain some insight as to if it really helps, if it statistically helps, but at the same time, you're getting better every year. If it's a long-term experiment, things are changing, and variables are changing. Basically, I'm getting better each year. The barrels are changing. The ranges we shoot are changing, so it's really hard to extrapolate what the tuner did. Mm-hmm. But ultimately, I was able to see things happening with the tuner, and it took using different velocities to do that.
Okay.
And if you shoot a same exit time, the barrel's in the same position. If it's moved, it's going to be darn hard to see it where it moved to. So I've always stressed to use 2 different powder charges, 2 different velocities, 30 to 50 feet per second apart. And then they will hit vertically to each other at 100, but adjust the tuner until they come together.
Okay.
That's actually reducing negative compensation.
So what is a barrel tuner? A barrel tuner is a device that attaches to the end of the barrel that allows you to tune the barrel harmonics in order to shrink your groups as best as possible. There are multiple types. Here at Cortina Precision, we have what we call the next generation easy tuner brake. This is a tuner and a muzzle brake combined. Now, if you're simply looking for a barrel tuner for your, let's say, rimfire rifle or even an air rifle, then the Easy Tuner V2 is probably going to be the best option for you. This tuner uses a spring to eliminate backlash and provide the most repeatable results. In order for you to attach it to your rifle, you can either have the barrel threaded by a gunsmith to attach the tuner directly, but that requires an inch 250 barrel, or you can use one of our adapters. These adapters come threaded in multiple different threads, half 20, half 28, 3/4 24. So you can attach this tuner to just about any barrel out there, including your rimfire or your air rifle. Visit shootsmallgroups.com, go to our store, and take a look around. Also, you can go on YouTube and search for Easy Tuner, and you'll see a lot of videos out there that show what our tuners can do for you.
So as a result of reducing negative compensation, which is, generally tuners in general, to actually make the slower bullets hit higher for longer ranges, you have to have specialized weighting, specialized offsets. You have to take into account the flexibility of the gun, the barrel, stock. There's a lot of factors that go into that for long range stuff. But for just your tuners or Dan's or Mark's or anybody's tuners, they'll accomplish the same goal with a movable weight, at least at 100 yards. And if you were to shoot 2 different powder charges, you would see that it only affects the vertical. Now, I've heard you say that, and I've heard a lot of people say the same thing, and including me, where it makes them wide and flat. And a buddy of mine was shooting one day, and we were experimenting with a tuner, and he says, well, it's wide and flat. And I said, okay, well, let me shoot the gun. And I put them in one hole. But I put up flags. Mm-hmm. So they were actually stringing horizontally because of the velocity differences, because it still affects it horizontally in a push.
Right.
And so we kind of got a laugh about it, and he says, well, you just got lucky. Do it again. Mm-hmm. And so I did it again. I said, well, where's this flat, wide pattern you're seeing? He said, well, I don't understand it. So, and I'm not saying that happens all the time, but usually the horizontal dispersion is another factor. It could be seating depth, causing a little random dispersion, and it's just kind of flattening it out because the tuner's getting rid of the vertical dispersion. Mm-hmm. So it's trying to work against the random dispersion, and you'll naturally see changing patterns. But ultimately, if you're using the same load and just shooting groups, you can see the differences. People can see the differences. We all know that.
Yeah.
It's just easier to see what the actual tuner's controlling by spreading things out to see them. You're only doing that to see them. And whenever I started doing ladder tests and corresponding POI to velocities, that opened up a whole new world. And a lot of people says, well, it's not accurate enough. You could have dispersion. You could have different things going on. I said, but we're 250 feet per second difference in velocity. If you can't see a change with that, you're never going to see a change with 5 feet per second difference. Right. Because it's almost the identical time where the barrel's in almost the same position. So it gets hard to see, and a lot of people get discouraged whenever they're adjusting the tuner and they don't see any change. And I can understand it completely because I've been there. And ultimately, whenever I try to discover exactly what tuners control, I talked to many scientists over the years, since about 2001, said, how can I measure the launch angles of these bullets? How is it possible? And every one of them had tried in some form or fashion over the years. And they said there's really no good way to measure exact launch angles. And we're still trying to figure it out. And Benet Laboratories years ago had talked about getting me up there. And we were going to try some experiment. It's going to cost me a lot of money, but I was willing to do it. And right before it happened, they went totally military. No civilians allowed in there then. And so I kind of went back and forth. And ladder testing was the only true way I could see what's going on. And as a result of that, of doing it over and over and over, you start realizing, well, that actually is the barrel movements. Now that I've done it 1,000 times, at first I had my doubts because a lot of times, basically your gun's going to bend the same and there's going to be a number of movements and you're looking into a window of those movements. But a lot of times a particular bullet has an exit time that is not in that area of movement. So sometimes you don't see much happening with a ladder. You'll see a generally flat line with all powder charges. That's a good thing. That's always good. It's when they start tracking down sharply, like roughly 3/4 of an inch per 50 feet per second. It really should only be about 1/3 of a bullet if the barrel's not bending. If you calculate it, the calculations will, any ballistic program will calculate it. The calculations will assume the barrel's not bending, same launch angle. So you have your base measurement you can compare it to. So as a result, we started comparing it further and further out as well. But at 100 yards, for, say, the loads to converge at 1,000, which is 1,000-yard bench rest, that's where I wanted them to converge.
All right. Before we go any further,
okay,
let's tell people what positive compensation is, because most people have never even heard that term. When I was interviewing Gordy Gritters, he actually mentioned that, and I believe he said some guy from Texas.
Yeah,
I believe that's you, and that's kind of how I got to you, because Speedy after that, Speedy sent a message to me, and he said, "This is who Gordy's talking about. Give me your number." And turns out you and I had already been talking. So
I see.
But anyway, so. Okay. Let's just talk about it, at least explain the terms that we're talking about.
Okay.
So positive compensation, what is that?
Positive compensation is when a slower bullet is aimed higher by the barrel. Negative compensation is when the barrel aims a slower bullet lower.
Well, okay, all right.
So we have two different types of compensation going on, not just positive.
Okay, let me make sure I get that. So positive compensation is when the barrel aims a slow bullet high.
Correct.
And negative compensation is when it aims it low?
Yes.
Wouldn't it already go low on its own?
Correct. But a barrel will aim it lower.
Okay.
And so if you're comparing to your calculated vertical and it's well below the calculated vertical, then you know the barrel's aiming it there.
Okay, perfect.
So
the way I understood positive compensation is just positive compensation to me was both. It's just a place where the slow bullets are aimed higher because they, so this is the idea, right? That the barrel's doing this. I'm exaggerating, obviously.
Yeah.
But because the slower bullet stays in the barrel longer, it gets aimed higher.
Because the barrel's moving up.
Right?
Correct.
And the faster one, because it's obviously the barrel doesn't have enough time or as much time to move up, it's aimed lower, right?
Correct.
So this is what it looks like, slow bullet, fast bullet. And because this is a slower bullet, at some point, they're going to meet up because the
Correct.
slow bullets is aimed higher, but it's slower, so it's going to slow down, and the fast one's going to catch up to it.
Correct.
And the point at which they meet is the point of convergence, or you can supposedly you can tune the barrel harmonics to the point that you can get them to meet up at whatever distance you're shooting at.
Exactly.
That's the way I understood positive compensation.
And any time you see an improvement, it's thought it's positive. It's always positive. But positive compensation describes the function more than the result.
Okay.
So just bear that in mind. Now, there's also a parallel node. Bill Calfee used to talk about this years ago. And let's say if you were shooting 100 yards, would you want all the bullets to hit the same height, any velocity? You naturally would, because you're shooting 100-yard groups. And if you run a graph with many powder charges and they all hit the same height, that's always a good thing. That means the barrel's not bending up or down during those exit times. And so there's different ways to set up the barrel. And a lot of times at 100 yards, if you have obvious negative compensation, your slower bullets are going to be hitting, say, an inch low. They should only be a third of a bullet low.
Okay.
And you say, well, okay, if you have 5 feet per second difference, it might hit a half a bullet low. So you've got to spread that out to see what that barrel's doing more than anything else. Not necessarily shooting groups. You're just trying to figure out if it's negative or positive compensation. And so that's ultimately...
So if I understand what you're saying is you are trying to see your results on paper versus the expected results based on mathematical formula or ballistic calculators, whatever.
Correct.
For example, according to the ballistic calculator, 50 feet per second should hit a third of the bullet low, but somehow it's hitting half an inch low. Something else is going on besides the ballistic, the external ballistics.
And that's the problem we had in 1,000-yard bench rest. I would put 4 in 2 or 3 inches, and there'd be one a foot out the bottom or a foot out the top. And I'm thinking it should only be 3.5, 4 inches, maybe 5 at most. Why is it 12?
So I've seen that myself because, I've been doing F-class for a long time, and we encounter many, flyers, right? And we've had the discussion of whether flyers exist or it's just simply showing you something that's actually there that we just are not familiar with.
I agree.
So I used to, because a long time ago, people were obsessed, I think until today, with powder charges. They throw within one kernel. And I do as well. However, I've thought about it and I go, well, to throw a shot 8 inches high at 1,000 yards requires a lot of powder or low. It would be a drastic difference in a powder charge. So there has to be something else going on.
Yep. Same.
And this is what you're talking about. Well, it's
and it'd be so irritating to have 4 in. I had 4 in an inch, and the flyer turned it into a 12, 14 inch group.
So what makes that happen?
Generally, the velocity variance and if it was the barrel was not bending, which mine's a barrel block gun. It's heavy barreled. You wouldn't think it would be bending, but depending on how much weight is offset above and below the barrel will determine how much it bends. And if you ever have a barrel in a lathe, you could literally bend the barrel with your pinky. If you put a dial indicator on, I could bend it 5 thousandths just lightly pushing on the barrel. So it doesn't take much.
Well, I've done it on a reamer. I mean, I put a reamer on, high-speed steel reamer, and they're only that long, pretty stiff. I put it on a solid holder, and I put an indicator on there, and it had a lot of run out. You know, even though I machined the holder in the machine, when I put the at the base, it was perfect. The hole was perfect, but then I indicated the reamer at the tip, and they had tons of run out.
Because it still had flex in the piece.
So I just went and put my finger on there, and like you said, it took nothing to flex that reamer. It was just all over the place.
And that's what it takes nothing to affect the barrel vibrations. I used to, when I was first checking weighting and different things, I would make these rings with a set screw in the side, and I'd just slide the ring onto the barrel and lock it in place. Well, one day I decided to see how much difference that little set screw made. So I'd take a shot, turn it a quarter of a turn, take a shot, quarter of a turn, take a shot, quarter of a turn, take a shot. I drew almost an 1.5 inch circle. And I couldn't believe it. That little set screw is enough to offset the movement of the barrel and change the dynamics that much. Now, as the years progressed and I started playing with weighting, a 1/2 ounce can completely change the pattern that you, on these graphs that we'll talk about in a minute. It's just amazing how little it takes to affect that. And unfortunately, you see it on the target a lot of times, and it's way more than the calculated. You're just like, was it wind? Anybody else have that problem? You know, you generally ask the guys next to you, did you have some vertical flyers? No, my groups were good.
My old style tuners and tuner brakes, they had set screws. That was the problem. People thought they were set screws. They were not set screws. They were simply tension screws.
Yeah.
And every now and then I had people go, hey, this thing it's like I go back and it just doesn't repeat very well. And I said, that's not my experience. What are you doing? Well, they would tell me, well, I try it. You know, I try a setting, then I loosen the screws and I turn it to a different setting and tighten them all up again. I said, no, don't do that. They're already set. When you get it, leave it alone, and it's got enough tension, just turn it. And all of a sudden they get consistency. It's the loosening, and because they would have never put them back the same.
Yeah.
So that's part of the reason that when we updated to the version 2, we got rid of the set screws. We added a spring, and because you know even this in the threads, right? So we put a 30-pound spring, and now we got rid of all the backlash and everything.
Well, in the tuners I built, with 1,000th shift in the weight sideways, any direction, that's 1 inch at 100 yards. It can change point of impact. And so a lot of the tuners that I built in the early days, they had to be almost perfect threads, no jiggle, or have a set screw in it. Now, if it changes it, that's not necessarily a bad thing to draw a circle. You're just looking at what it's doing to the barrel. Doesn't mean it's going to hurt the accuracy of it, even if it deflects at 2 inches. As long as you don't jack with it in between shots, it won't hurt a darn thing.
Right.
But it gives you an idea of how perfectly centered and everything. I mean, I machined everything under a 1/2 thousandth of an inch on my tuner. At least the one I researched for about 7 years, the same tuner on different barrels. And it never hurt anything, but I always tried to see by doing quarter of a turn increments how much that I got it centered, and how much I reduced that tuner deflection is what I call it. And it reduced it, I'd say, down to about a 1/2 inch, roughly, on my best day. And that's with everything perfectly machined inside and out, threads, holes drilled, everything symmetrical. So it's not a deal that'll hurt you, but if people move it and they say, well, my group's moved around in a circle, doesn't matter. That's just tuner dispersion. That's not our tuner deflection, should I say. It's not going to create a dispersion issue. It just means because your group's moved in a circle, you happen to be turning the tuner and shooting groups. That really, it's how those groups group more than anything else.
Yeah.
And I've heard a lot of people talk about that.
Well, that's one thing that, people have heard me talk about how I move my tuners. And this is after I talked to John Myers, and he explained how he used tuners and all the research he had done. But the best thing to do is find a spot where it's happy and just leave it alone. Don't touch it. That's going to work for 99.9% of people.
I agree.
I'm in competition. I'm trying to shoot 5-inch or below groups literally all day long. That's why I'm moving my tuner.
Yeah.
You know, it's and people think, well, there's, you know, you have a secret, you should let it out. Well, this secret is probably going to hurt most people's results rather than help them, because
everybody's got to find their own way and their own niche.
Well, yeah, yes and no. I mean, the best way is find a spot that works, that has a wide node or window, and leave it alone. Just put it in the middle, leave it alone.
And if it works, if you decide to play with it, don't move it much. Just go either way.
Yeah, and that's going to work for you. That's going to work for most people, and that's how I did it for 15 years.
I agree. Yeah,
now I'm playing with it a little more, but it's just because I'm trying to squeeze just a tiny little more, always. You know.
And see, this is where I developed the 2 powder charge method, because I would get to a match and the gun shot a 5-inch group. Well, I was thinking, you know, I had 4 in an inch. I put one out the bottom. I might need to tweak that tuner. Well, sometimes it'd make it worse. Sometimes it'd make it better. What I call tuner trauma. And I was like, God, I should have just left it alone. Oh, I should have just left it alone. So the next group comes up, 3rd relay, and I put it back where it was, and we're back to 5-inch groups. And I'm like, you know what? I'm going to leave it alone. So ultimately, I was never really 100% sure if that tuner was set to the maximum potential.
Right.
I was always second guessing it. And that's the hardest thing about just leave it alone. So over the years, once I figured out exactly what tuners do, how they control vertical, I used 2 shots. And once I would go to the bench at a 1,000-yard match, and you've got 7 minutes for sighters, shooting the dirt clay pigeons below the targets. And when you're done, they would say, time, get ready to go for score, and go up to paper. Well, what I would do was, first thing I'd do is take 2 powder charges to the bench, and I'd shoot them. If they hit level, I put them to the side. I know it's in tune. That's as good as it gets. You can't get more level than level. And then I would grab my ammunition, my competition ammunition, and start shooting in the berm, bracket the wind, make sure the bags are set, you know, the usual stuff. And I always did good, but I can't tune that wind. So I didn't just set that world on fire by using positive compensation. But ultimately, every single time I went to the bench, I knew without a doubt that tuner was set the best way it could be set, simply because I used 2 different powder charges, 2 different exit times. And positive compensation made them hit level at 1,000. That's actually where the barrel's moving up. And at 100, that meant those same 2 powder charges, the slower bullets should be hitting around .700 higher to make that happen downrange. So you can use your 100-yard measurements as a direct map of what will happen downrange as far as the barrel aiming the bullets. So that method has worked for 7 years on that tuner system. But ultimately, it depends on the pattern the tuner makes.
So I'm going to have to ask the hard questions.
Okay.
So you shoot bench rest? Is that your thing?
Mm-hmm.
Are you like lighting the world on fire? Because that's, you know, that's going to be that's always the, well, yeah,
Absolutely
but how's
not.
it working?
Well, you can't tune out wind. That's one thing I learned. My rifles will outshoot anybody's, but
You just can't prove it on target?
I can't prove it on target. Sometimes I suck just like everybody else. But I tell you what, in bench rest, you'll get a cluster of 4 bullets or 3 bullets. And I always used to joke and said, man, 5 is a cursed number.
Mm-hmm.
If I had 4-shot groups, I would have won the Nationals numerous times.
Shoot 6. Seriously, so no, seriously, idea. This is what I tell people. And they're like, I just can't, I'm not good at shooting 5-shot groups. And I'm like, shoot 6-shot groups. You know what I mean? And obviously in practice, I says, shoot 6 and you get to throw one out, you know, in practice, and see if that really, because then mentally, I think it may be a mental block that we have.
It could be. It absolutely could be.
Just the reason, I used to shoot pool for a while, and everybody would just kill it until they got to the 8 ball. and they'd always miss the, not always, but typically miss the 8-ball on easy shots, right? They hardly ever miss any other ball. So, and I would do the same. So I would come home and only shoot the 8-ball.
Yeah.
I would practice by only shooting the 8-ball. And then when so anyway, so shoot 6-shot groups.
Yeah, that's a good idea. I'd like to try that. And it always worked out, though, that ultimately I had no vertical. And that was the main goal. That's all you can expect is no vertical due to the barrel harmonics and the velocity variance. Now, years ago, we were in a Texas State match out in West Texas, and I shot a group. A buddy of mine comes up and he says, "Now, what's your definition of tune?" I said, "No vertical." Simple as that, no vertical. And so I shot my group. It came back around 16 inches wide. And you could lay a straight line on that target, and it would match the bullet exactly.
So
I was so proud of that.
This is what Speedy brought me.
Yeah.
And now Speedy has a whole different, flip it around, or actually let me put it on cam 3.
Okay.
So that people will see what we're talking about. Speedy brought me that, and he said, according to him, you need more powder, And I don't shoot bench rests. So.
Can't dispute him. The guy's just done so much for me, and he's been right so many times. You just can't say that. Well, I don't know. No.
Well, so here's the problem that I have, and not with that, but the problem that I have with people thinking it's only one thing, and
it could be.
And I'm not saying you. I'm just saying people. Like Jack Neary discussed that. Speedy did as well. He brought sample targets, and when people saw that, they go, "Oh," and they say, "Hey, so my groups are shooting like this. What did Speedy say to do?" And I'm like, "Well, it's yes and no. It's you have to have everything else wire tight, as they say, so that when you finally get to this point." And the reason Speedy knows that this works is because his equipment, his entire system is to the point that it will respond to these things that he's doing, right?
He knows.
Not everybody is at that level, or everybody's equipment's at that level, right? I mean, these guns are shooting zeros on perfect.
Well, there is one way to explain this.
Yeah, so go ahead, please.
Vibrationally speaking, anyway. There's a vibration that's actually a vibration. Meaning vibrations are multidirectional. A tuner is not going to control necessarily a vibration. Since it controls vertical, you really can't call that a vibration. It's just a vertical distortion of the barrel under recoil is what it is. That's what the tuner affects. Now, they have a high frequency vibration. Now, discounting the firing pin falling and everything pre-ignition, let's talk about after ignition and before the bullet exits. There'll be a high frequency pulse. What this is, and we actually stopped the tuner research for almost a full year just to figure out what this particular problem was with high frequency and how to reduce it, how to eliminate it. High frequency is the case slapping the chamber at 60,000 PSI and the bolts locking up. So we were adjusting the tuner one day, and I got to a particular powder charge, and it scattered. The tuner stopped adjusting them vertically. They were just all over the place. And I'm like, okay, I went a half a grain more and a half a grain less. They all went back to straight up and down. The tuner adjusted them out. Okay, so what is going on here? This is right in the middle of my window. And so I went back and did a lot of research, talked to a lot of scientists. They all agreed what my thoughts were on it. So we went back with a different bolt, different firing pin, different shroud. I custom fitted everything to the action and started changing out parts. Okay, it still sucks. Groups are still big, 14, 18-inch groups. And changed the firing pin, no change at all. And so what I speculated, if it is actually high frequency, let's try some neck-sized only cases, not full-length sized. And instantly the groups came down to about 10 inches. And we repeated it about 4 times. I'm like, okay, let's go back to full length. Got big again. So we said, okay, that's definitely indicates it could be high frequency.
Before everybody jumps to conclusions, we're not done talking. Yeah. He's not saying full length sizing is bad.
Yeah, absolutely not. Absolutely
we're not there yet.
But it's just for finding out what's causing the vibration.
Yeah, yeah.
And if the vibration is at the muzzle, it is only at the muzzle one period of time within your whole loading range. Okay, so if you get to particular powder charge and all of a sudden your groups get huge or flat and wide, and they weren't before that, and you can go a half a grain either way and it's good, that is high frequency at the muzzle. This high frequency pulse will hit the muzzle about 7 to 8 times before the bullet leaves.
Okay.
And the bullet can actually carry the high frequency with it, causing the bullet to be unstable as well. So that was pretty interesting. I talked with scientists, and he sent me a white paper report on a Navy lab on 16-inch guns. Had the same problem. He goes, the way to fix it, simply change powder charge.
Yeah.
And that will get rid of it completely.
At SHOT Show, I showed Brian Litz my tuner testing. This is after he had released his book. And I showed him, and he looked at it, and he says, well, can't argue with that. The thing, and we discussed this when he and I talked, and he said the thing that he noticed was that the velocities at the target were much better with the smaller groups. It was the exact same powder charge. The only thing I was doing is changing the tuner. Now, I can't say that I really trust the velocities at the target, at the electronic target. However, I did it 4 times, 4 different groups, and they all matched. The big ones had higher ES velocity at the target. The smaller groups had smaller ES at the target.
I see.
Possibly we discussed, and I don't know if we did on the podcast, the possibility that the tuner is affecting the vibrations to the point that the bullets are not getting destabilized. That it sends the bullets out of there more stable.
I think it's more to do with muzzle launch dynamics, muzzle blast.
Yeah, again, I don't know. Were
your tuners flush with the crown?
No.
They hung over. Will you have a recessed hole?
No, they go over the barrel.
Okay. So there's nothing in front of the crown that could change that? Okay.
Nothing. Speedy, we do make adapters for those that want to hang it over. Speedy thinks it's better to hang it over. I don't know if it's better. I don't like it because I don't like cleaning the barrels that way. It's a lot easier for me to clean the barrels. Plus, I just don't like them hanging over because it makes the barrels longer. All of a sudden, they don't fit in your gun case. Yeah. However, Speedy swears by them. So I'm going to test that. But anyway, the point is mine are behind the crown.
Okay. Well, in another case now, it could be a little bit of high frequency at the muzzle, causing dispersion. Inboard timing varies. You really can't pick it up unless you're tracking the graphs and so forth, tracking the point of impact with velocity, attaching a velocity to each shot. And, there's a lot of things that could make it appear that the tuner affects that, but I don't know of any mechanism that would actually make the bullet stable just because you're moving a weight on the barrel. I couldn't think of anything that, other than seating depth, maybe is right on the brink of affecting it and not. I've been doing a lot of testing lately on seating depth, and bad seating depth, makes groups grow. Not all the time, but sometimes it does. When it does, the BC drops slightly, and a velocity drop from the muzzle to the target drops more. Only on the bad seating depth. If you put a good seating depth on there, the groups get better. At the same time, there's less drop from the muzzle to the target.
That means the bullets are more stable when they leave the barrel.
Exactly. So that has something to do with it, I believe. I just can't really define it right now without knowing all the perimeters of the gun and the test and all that. But that's what I'm seeing. And I'm doing a lot of research on suppressors lately. And I've got a suppressor that you fire 2 shots through it and get the oxygen out of the can. And all of a sudden, velocities and the BCs are identical to the 100-yard target. The same exact drop, the same exact BC to the 4th digit for 5 shots in a row. Mm-hmm. After that, they start varying again. And so we repeated that about 4 times, and it was exactly the same result each time. So I'm doing some stuff. I'm going to purge the oxygen out of the can with a good seeding depth. Mm-hmm. Now, I can put a bad seeding depth in there, and immediately you see the BC drops. They're very small, so you have to use large samples to gain that. But what I'm watching more than anything is the velocity drop from the target, or from the muzzle to the target. And if it's a little more, you know the bullets are wobbling more, and the group just confirms it, that the groups grew. So there's a couple of things going on I'm really not sure of as far as the muzzle blast goes that has a great effect. Now, what I can say, and I hope I don't offend anybody with this, but the muzzle blast is affected by the muzzle brake. And it can cause, if your bullet's especially unstable as soon as it leaves the barrel from either a center of gravity offset, meaning it was squished into the barrel, it's now a new shape, it's got to find a new center of gravity when it leaves. So you get just a second there where it's wobbling a little bit. At least everybody says so. I'm still having trouble measuring it, but I'm getting there. But a radial brake has the least effect on this. Side port brakes have the worst effect on this. At least my side port brakes. Now, I can just suck at making brakes. That's entirely possible. But mine are basically flat baffles, nothing fancy. And I would love to test some other brakes to see if it actually drops it. And so we were out with my Shy Tech the other day, and a buddy of mine says, well, take your brake off and see if it's better.
Yeah.
With a Shy Tech.
Well, just take it off.
Okay.
Be a man.
I can handle it. So I put a wussy towel on my shoulder and took a shot, and it just about knocked me off the bench. And I said, we're done. I don't care about, I'm going to do,
yeah, you don't, all of a sudden you don't care that much about it. So. All of a sudden the research is not as important as your shoulder.
Yes, exactly. And I was just afraid that we need to do some more research on it, because you can always be misled by data. Absolutely. So.
I don't know if you've seen my brakes, but the holes are bigger at the beginning for that. It's to strip as much gas off that bullet as possible. And most brakes have, 30 thousandths over bullet diameter, so all the baffles. Well, that just means the first port does most of the work, right? So talking to people that actually have patents on brakes and things of that nature, they are the ones that said, make it oversized. And that's going to give you the maximum, efficiency on all the ports. So we did some pictures, and sure enough, all the baffles work at the same time. But the whole point of this is they were supposed to. Again, I don't have a way to measure any of this. Yeah. They're supposed to strip the gases away from that bullet and let it stabilize if it doesn't leave stable. That's what they told me. And again, I was like, okay, so we did it, and they shoot fine, so I left it alone.
Well, years ago, I was talking to Bill Shahane about that at one of the Nationals. And as a matter of fact, Gordy was there too, I believe. But we were sitting down kind of talking about brakes, and he says, well, your holes are good and everything. He says, but when Vias started making brakes, he said, hey, are you going to be shooting 1,000-yard? Are you going to be shooting big bullets? What? And the smaller calibers had one less hole. He would say, if you have a 30 cal doing this, get the one with the extra set of holes in it. And I believe it was Vias. It could be another, but he was pretty much the only one at the time, I think, making the radial brakes. But it made a difference. And there was guys using aluminum ones, trying to keep from changing the barrel harmonics, which, of course, it did. Yeah. Even though it was only 3 ounces, it still changes it. And so there's a lot of dynamics going on with the blast itself. And Harold Vaughn did an interesting test. He would use a piece of paper and put it right at the muzzle, and then he would shoot a bullet through the paper and look at the pattern of the blast on the paper. It was different every time. But as a result, he could correlate where the bullet hit sometimes and sometimes not. So it was inconclusive, but I was surprised to see there was a different blast every time. Each pattern, it would throw, it'd have a primarily up in the left corner and lower right, and the next one, it's all even all the way around, and then it would go back to this, and then it would just change.
Were they the same powder charges?
Mm-hmm. Oh. It was supposedly all, I need to reread the book. It's been quite a few years, but Rifle Accuracy Facts is the book. But, he did a lot of things that was really interesting, and I've always tried to follow up on where he stopped. I tried to continue from there and get a little more specifics as to what really is going on. But with an older system I have right now, the older 89 system, measuring the drop from the muzzle to the target has been real critical. I used the lab radar. Well, sometimes it would pick it up at 100, sometimes it wouldn't. It was irritating because I was using a lot of ammo and couldn't get all my readings. So I ultimately set up the older 35 at the target and an older 35 at the gun. And so we have corresponding chronographs, and we would shoot 25 to 50 shot samples across it, and to see if, how the drop was actually happening, how much drop was happening across that given distance, with bad seating depth, with and without suppressors, with and without brakes. And you could actually define a difference. Now, granted, it was around 3 to 6 feet per second, depending on what we were testing. That's not very much. You've got chronograph error you can stack on top of that.
Yeah.
So you have to do large samples to try to get around the noise. And we're still confirming it, but each time I went back, I did 3 separate tests on muzzle brakes. Each time, after we averaged it, each one, and as an overall, the average came out to 3 feet per second difference. So each time it's coming out the same. And so there's still a lot more to learn on that, but as far as the tuning goes, if you have high frequency at the muzzle, the groups are going to suck no matter what you do. You can turn that tuner all day long, and it's just going to change the shape of the group. Now, a lot of guys
change the shape of the big group.
Yeah, and a lot of guys could be saying, "Well, my tuner's not doing nothing." Well, try to change powder charge. Get off that high frequency at the muzzle, and I believe that's what Speedy's talking about. Mm-hmm. Is just change exit timing. Now, in my case, the high frequency was at about 2750. I'm never going to be there. I was just doing graphs and happened to be there, and it was right in the middle of my window, and I'll never be there. Normally, I'm up around 2850. So a buddy of mine says, well, just stay away from that velocity, and you're good. That's how you deal with high frequency.
Simple.
So
I guess some of the things that we need to discuss before we keep going is, obviously, you believe that a barrel moves before the bullet exits.
Absolutely does.
Okay, because I had Eric Higgins on the podcast, and he didn't believe that it did. And I asked him questions, how come different powder charges impact different on target, and he thought maybe it's just a shooter or whatever else. So there's and he's a pretty smart guy.
Yeah.
So there's different beliefs. So I guess obviously you believe that the barrel moves before the bullet exits.
Absolutely.
Otherwise, it wouldn't affect it.
We wouldn't have to tune guns if that was the case. Guns wouldn't go out of tune.
Yeah. Number 2, positive compensation. We're going to discuss that and how to tune for that.
Okay.
Alex Wheeler prefers a flexi stock. He said he's a bencher shooter. And
Speedy does too.
Renowned gunsmith.
Or just the right flex is what he used to tell me.
Yeah, and so obviously they believe in positive compensation. Every time, for the longest time, people ask me about positive compensation. I say I don't believe in magic. So hopefully today we're going to explore this.
You could describe positive compensation as, well, I had a lot of velocity variance, but they all still went in the hole.
Yeah.
That's ultimately what positive compensation is.
Yeah.
And so if you can't explain it, that's the way to at least a term to tack to it anyway.
So, and obviously you've been talking about the testing you've been doing. Let's talk about the equipment, because I'm afraid people are going to take any rifle and say, well, it's hitting here. Because, not all rifles, not all systems are good enough for testing things like this,
absolutely.
right? If you don't have a consistent rifle gear equipment, then it's going to be hard to test anything.
Yeah.
So what is it that you're using to test these things?
Generally speaking, I used all the best equipment I can. Best barrels, best bullets, best brass, best powder, best primers. When you get starting in, when I first started in bench rest, it was a myriad of just, what do I pick? All these different components were available. You talk to the old farts and they'd say, oh, do this, 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 this. So it's still a separate game as far as weeding out the inaccuracies of the gun itself. And the tuner is just putting it on top of that. So in my case, I would use the best barrels and I would shoot the gun immediately.
Well, the gun in question, is this a bench rest rifle?
Yes.
Is it a bag gun or a rail gun?
Bag gun.
Bag gun, okay.
Bag gun. I mean, I've had some rail guns that were the same.
Okay.
But the rail guns only left me hanging, always. Meaning that if you had a drop of 30 feet per second, it dropped out the bottom of the group on the target, no matter what you did. And I said, there's just no way for me to get level velocities for more than 10 shots. It's just.
You think they're too rigid?
Yeah, absolutely. And that's what you're trying to do, is reduce that negative compensation, meaning you don't want the barrel to aim them lower. You just want it to not aim them high or low. You just want it, it's parallel.
Right.
And that works great. But then you're still dependent on velocity variance downrange.
Right.
So that's what you run into. But the equipment itself, you've always got to confirm good groups no matter what. And there's a million ways to do it. You can just leave the tuner on there and just leave it in one spot, tune the gun to it. I believe you've advocated that as well. And that's a great way to do it. And if you can't get it to shoot by normal tuning, then the tuner's certainly not going to help.
Right.
And so once you get it there and you're shooting one whole group at 100 yards, there's no reason to touch that tuner. You're good. But if you can't get it to shoot one whole groups and you say, well, let's try to turn the tuner, let's see what happens, and it doesn't fix it, you can't say the tuner didn't work. You gotta it's just a weight. It doesn't, make up for everything else.
Yeah, it would be the same as a gun that shoots bad and you change the powder charge and you can't fix it. You can't say that changing powder charge doesn't.
So you've got to determine what it is. It could be the barrel, it could be the bullets. So you really, it's always a guess somewhere along the line of what's the problem with the gun. But the last 10, 12 guns that I've built for me personally in competition, you just don't see that anymore. I don't see the bad groups. I don't see the dispersion that I did when I was younger and was inexperienced. For some reason, I'm a better shooter now.
Yeah. So let's talk about how a tuner affects the groups versus seating depth. Because I've lately, for the last couple of years maybe, I've pretty much quit doing seating depth. I just pick one. And then I just adjust the tuner.
Well, many years ago, I was doing studies on seating depth, and I was using a factory Remington Sodero. Good shooting gun, shot great. But the lead angles on the throat were extreme at 4 degrees. That's most of the Remingtons, I believe they were around 4 degrees per side.
Wow.
That's like a step.
Yeah.
It's not a ramp, it's a step. So I could, you had to watch your run out on the bullet, because it would affect it. But the seating depth would cause two problems. It would cause random dispersion, and it would level out your velocities.
Okay.
So your velocities, if they're not level, positive compensation can help that.
Okay.
But the random dispersion, tuners don't help that. Tuners are not going to help a wobbling bullet.
Right.
They're not going to straighten it out. It's not magically going to bring it back on the trajectory, anything like that. So that's where a lot of people get confused. They think, well, part of tuning your rifle is seating depth. And they think that if you adjust your tuner, you're doing the same thing by tuning seating depth. And you're really not. You're trying to get rid of that dispersion by shooting a good group. Hopefully with level velocities, they both hit at the same spot. That doesn't necessarily happen, and you've probably seen that too, where velocities were really level, but the group sucked.
Right.
Or vice versa.
Right.
And so it depends on if you have that random dispersion. Now, years ago, I talked to Dave Kiff about this problem, and he says, hey, I got a solution for you. Let me send you a reamer. And what he did was lay down the lead angles to 1.1, 1.3 lead angles. And that changed everything. Number one, throat erosion was slowed drastically by doing so. And the dispersion that I used to see, it was really hard to, I mean, you would still see maybe a 1/2 inch, 3/4 inch group, and you could change that. But that's almost to the point to where you're saying, well, it might have just been me. And so I don't see the kind of dispersion problems with seating depth on the newer throats.
So back to the tuner versus seating depth. Okay. What does seating depth do versus what does the tuner do?
Seating depth will get rid of the random dispersion, makes the group smaller at 100 yards anyway. Okay.
Smaller or consistent?
Smaller,
or both,
bigger. Depends on where the depth is. Sometimes it doesn't affect it at all. And you get long strings, say if you're going, excuse me, 5 thousandths jump, you may get 20 thousandths there where it doesn't change the group size. But I got to the point to where, since with these new throats, it really doesn't hurt you too bad. Only on factory guns with real steep lead angles, it hurts you. But I get to where I'm just watching the chronograph. I'm changing seating depth until I see level velocities, not even really worrying about groups right now. And even then, say the first 200 rounds of the barrel, your inboard timing is always changing. And so generally after 200 rounds, that's the time to start playing with seating depth because it's starting to level out inside, getting the lumps out of the barrel. Now, and a lot of times, believe it or not, the bullet can actually slow down as it starts to break in. The inboard timing can. You may not necessarily see it in your velocities, but if you have a graph and you know that this powder charge is here at this point of the movement, and all of a sudden it's 2 grains later at the movement, but it's the same velocity, you're like, what happened? And it was the actual position of the barrels. It's in a different inboard timing now, so it's naturally in a different position of the barrel. So you're able to see some of these changes going on, and generally after 200 rounds it levels out, and then I'll do my final seating depth test to make sure it does group good and does in fact have level velocities. Now everybody always said to the granule, certain primers, do all these different things. But we were doing a test one day with a friend of mine, Otis, and he had some of these Dallas, or he had some guy reload for him, okay? And the seating depth, you could almost see the ogive going inside the neck. It was so far down in the neck.
Okay.
Got to fit every gun. So,
yeah.
And so he asked me, he's got horrible velocity variance. He couldn't hit the targets. I said, I'll be out there. So I brought a little hand press that I use in my lap. It's a Lee press, and we hammered some of his bullets out, just enough to be able to reseat them. So we found where the bolt would close, and then we started bumping them back. And he went from about, I think, 45 extreme spread velocities and not hitting the target one. All of a sudden, now they're level, and he's hitting the targets. And I said, okay, keep this bullet. Whatever the OAL is, use that for your reference for the rest of the bullets. He said, well, go ahead and push the rest of them. Okay, fine. So I did it, and he tore it up after that. And I said, if anybody ever tells you the seating depth doesn't matter, you saw it right here.
Yeah.
And his ES was around, 12, 14.
Why does seating depth change extreme spread, or your velocity?
I wish I could answer that
consistency
question. All I can do is relate it to it right now. I'm assuming by the way it slugs into the barrel, generally if you have a large jump, your shot start pressure is reduced, meaning it had a run at the rifling.
Right.
And if it hits it crooked, that's where you have either inboard yaw, meaning the bullet's wobbling as it mechanically is held in the barrel, and it takes time to settle down when it releases it. Or somehow the carbon can get around the bullet just long enough to form a seal and give you more consistent velocities. That's the only thing I can say right now that I can just correlate it to. I never could find a reason for it.
Yeah. All right. So positive compensation.
Okay.
How do I tune for it?
Essentially, with an average tuner, like your tuner on a regular gun, check the pattern. Okay, let me draw a graph here. Let's see. Say for instance, 96 grains, 95, 94, 92, 91. Okay, these are your powder charges. And I start on the right side because I'm working up my powder at the same time. Okay. So I kind of do it all at once. So I start slow, and on my 300 Win Mag, we have it hits here right on the line. So I'm aiming at that line the whole time. I move left and go with a faster round, and it hits higher, okay? That right there is not positive compensation because the slower round or the faster round is actually hitting higher.
Okay.
See what I'm saying?
Yeah, we're
going backwards though, but I'll show you why in a minute.
Go ahead.
And so now
use the red one so we can see a little better.
Okay. And so now that we shot our second round, we're going to go to the next hotter round, and I'm watching for pressure as I go up in powder charge. And now it hit lower. And you're like, oh, that could have been a fluke. Mm-hmm. Anything could be it. So you shoot a faster round than that. Now, we're talking 200 feet per second faster than this round, okay?
Okay.
So now it hits lower than that one. Okay, well, that's still not proof. So we shoot 95. We find out it's hitting lower than all of them. Okay. Now, this is where the doubters say, well, that doesn't prove anything. If you hit lower than this round, that could be luck. Uh-huh. But what are the odds this is going to hit lower and this is going to hit lower?
Yeah, it's the pattern, right?
It's a pattern. And then ultimately, the pattern at the end is hit lower than all of these. Now, this is time where you can do deductive reasoning. How is that possible? There's only one way: the barrel aimed it there. There's no other way that can happen.
Now, how many shots on this test per test?
2, 3, 6 shots.
Oh, just one shot each? Mm-hmm. How many times do you do this?
You don't want to shoot groups. Everybody, and I understand that, and it'll still come out the same in the end. You find your error in your groups.
Yeah.
And so if you're shooting crappy groups, you might as well not even waste your time with the graph. If you happen to be shooting good groups, you know the gun's a good gun, this is when you would shoot the graph to see what's happening.
Okay.
It's not hard to do. I've had guys that have never shot hardly at all grab my gun, and I said aim at the line, and they shoot a perfect graph, a representation of what I just did. Mm-hmm. It's not hard to do.
Okay.
So ultimately, this tells you what your gun's going to do downrange. You can relate.
What are we looking for?
Okay, now this is the tricky. The left side is the fastest bullet. Okay, so that represents the beginning of the movement. It's the earliest exit time.
Okay.
This is the latest exit time. That's the end of the movement. So we can just look at the movement and say it's rising as they get slower. Okay. And then all of a sudden it drops. What I call the cliff of death is this part right here. And generally speaking, if you were to go even slower, that last bullet would be way down here. That means the barrel's actually reverse direction and moving down. The downward swing is about 5 times faster than the upward swing.
All right, so this is 5 different tests. Mm-hmm. A full grain apart.
Full grain apart.
So you go to max and back off from there?
Use your whole loading range in the book. That's the easiest way to do it.
Okay.
And you're looking into a window of the movements.
Okay, so I see this example. What am I looking? Where's the good spot?
Right here. Anywhere in here. Where the bullets are tracking up as they get slower. Now, the convergence point. the steeper this angle, the further the convergence point, meaning the barrel's moving upward at a higher rate. So the higher the rate, the further out it converges.
Okay.
This is not easy to do. I'm showing you examples that is hard to achieve by anybody. Okay, so I'm just doing this to show you what we want to see, is that the slower bullets are hitting higher as they go slower.
All right. I'm still a bit confused.
Okay.
So you said from 96 all the way to 92 is where I want to be.
Yep. Anywhere in that window, and you're tuned.
So any of those charges will shoot.
Now, let's say 94 grains is what you pick.
Okay.
Okay, let's say your velocity variance is not 250 feet per second, but let's say your velocity variance is 10 feet per second. So basically that bullet would be somewhere around here.
Okay.
So it aimed at a half a bullet higher if you've got 10 feet per second. If you were shooting at a target and you knew it was going to be slower, would you aim it a little higher just to be safe?
Possibly.
So this is what this particular rate will do. If it's 10, if it's 20, it'll be around here. It'll aim it roughly a bullet higher. So everybody says, well, it's going to aim this and that. And well, if your variance is small, it only changes it small. You know what I'm saying? Does that make sense?
So any of those charges will work.
Now,
define working.
Okay. Basically, at 100 yards, let's say you did another graph. Let me draw another graph here. And let's say you shot okay, now fast, slow. Okay, now here is where the barrel's actually moving down, because as they get slower, they're hitting lower and lower and lower. They shouldn't be hitting that much low. You know, that's roughly 2 inches lower from here to here.
Okay.
And so if you were to pick a powder charge in this area, you would be fighting vertical all the time because it's exaggerated vertical. Does that make sense? So really the only spot you could use in this graph is right here. That's where you would be in tune. So anywhere you see the slower rounds hitting higher in that window, that's your tune window right there.
All right. So the slower rounds hitting higher. So put numbers on there just like.
Okay, let's say 96 grains and 95, 94, 93, 291.
All right, so 94 and 95 appear to be flat with each other.
Okay, now let's say you did shoot that.
Yeah.
Okay, now if you're shooting at 1,000 yards, your barrel's not aiming the bullets higher or lower. It's just straight. You're parallel.
Okay.
So if your velocities are level, it's going to shoot lights out.
Okay.
But if they're not, what's going to happen?
Let's say it's 50 feet per second. So when it's flat like that, it's going to do.
It's going to drop down range because your barrel's not.
No, what I'm saying is when it's flat like that, you're saying that the barrel will do exactly what the velocities say it's going to do. It's going to track. So for example, if you have a slow shot, it's going to go low. If you have a fast shot, so if you have high ES, then it's going to have a big group.
Yep.
You have to have. But if it's flat like that and you have really good ES, then it's going to shoot.
Yeah.
So there's no compensation at that point.
Yes, correct.
Okay.
But now, if you shot right between here and you were, say, 30 feet per second slow at a 1,000-yard target, you would go to your calculator and calculate and says, okay, 3.9 inches for 25 feet per second. Well, you go down there and say it's right at 3.9 inches. So it matches your calculated vertical. That means the barrel's not bending up or down.
So would that be a good place to be?
It's not a bad place. And most tuners will do that just fine at 100 yards. Okay. If you're shooting 100 yard, 200, 300, out to 1,000, that's a great place to be, even for 1,000. Because you're never going to, what's your worst ES you've ever had in the string? What, 20? In competition?
I don't know. We don't get to measure in competition. We don't get to have chronographs.
Well, I'm going to say probably,
but I'll tell you this. I shot a group on video, 1.3 inch group at 1,000 yards, 5 shots, and the ES was 19.
Okay.
Most people didn't notice that.
Okay. Let's use that for an example. Okay, so you had about an inch vertical at most, right?
Yeah. Yeah, it was tiny.
And your ES was what?
19.
19. So you calculated on a ballistic program. The ballistic program is going to probably say close to 2.5 inches.
Okay.
You're inside of that.
Right.
So either the wind blew you in or you had positive compensation.
Okay.
It aimed up, in other words, at 100 yards, it aimed a bullet about a bullet and a half higher when it got slower, meaning the barrel was moving up.
Okay.
But if it was parallel, it would have dropped out 3.9 inches.
So if I would have had really good ES, the group would have been bigger. Or it would have been whatever.
Whatever you calculate it to be. Correct. Because the barrel's not bending.
Okay.
So whatever your ballistic program says, that's what it should be.
Okay.
And it varies from one ballistic program to the other. Come to find out that conditions has a little bit to do. It changes the calculations for whatever reason. I really don't understand that completely. But that's your basis to use as a comparative for your vertical dispersion.
The first 4 shots went into a 1/4 inch out of 1,000.
And if you had big velocity variance, that's positive compensation is working. It's just too small to gauge. That's why I stress to spread out the velocities and shoot this graph to get an idea. If your barrel's moving up, down, parallel. Now, if they were all straight all the way across, barrel's not moving.
Okay.
And that's great, especially for a 100-yard group. I shot one of my best 100-yard groups with 3 different powder charges a grain apart, all mixed together. Because my buddy said that. He says, well, you're all flat all the way across. And I went, ooh, that's a good place to be. He said, well, shoot a group. You've got these left over. And so I just mixed them all up and shot I think it was like a 081 group. And I'm like, oh my God, that's the best group I've ever shot in my life. Why couldn't I do that with one load? And it's because I knew that the barrel was not bending up or down, negative or positive. And with a tuner, the weight determines the pattern, and the inboard timing of that particular bullet will also determine where it's exiting in the pattern. And so you may not even be exiting on a good pattern simply because it's the wrong bullet. Say if you put your tuner on and say, well, it's not making much of a difference. Well, if you run a graph and the graph is flat all the way across, you're like, well, there's really not much happening right there. The barrel's straight in that window of exit time. So try a different bullet. Whoa, this one, now I'm on the upswing. Now I've got a common pattern is just a simple sawtooth pattern. That is almost every gun out there with a universal tuner. If this is the case, okay, now let's say this is the faster loads and the slow loads. Where would your node be?
I have no idea.
Right here, right here, right here, right here. That's where you want to be on exit timing.
So you want to be on the upswing from fast. Okay, you want it to, as they're going slower, you want them to be going up.
That's good. Bad.
So
Real
bad. Duh.
That's
all right,
the bad.
All right. So as they're slowing down, you want them to be going up to compensate. Hence,
now, just because it converges at one distance, if you converge it at 800 yards.
Oh, hang on. Let me make sure I get this straight before we move on. You, as they're going slower, you want them to go up to compensate for the loss of speed. That hence positive compensation, right? Is that
exactly?
Am I there yet? Finally,
exactly.
Got it.
You are there.
All right. I had to put it together. Now I get it. So you want the barrel to compensate for the slowing down. All right. Got it.
And when it's going down, it's actually anti-compensating. It's the opposite. It's making it worse. It's increasing the velocity variance, or increasing the vertical. For a very small velocity variance, you get huge vertical.
Yeah, it's maximizing the effects.
So now on your tuner, let's say that your powder charge happens to be right here. Okay. Now, say it's 95 grains of powder. You probably don't use that much, but
no,
I'm still in the ELR state here. But now, if you were exiting, let's say here, you're in a bad spot, you got a lot of vertical downrange, everything sucks. Life sucks right now. So how would you put that here?
Well, you can increase or decrease powder, right?
You could do that.
Well,
or now when you adjust your tuner, the movable weight will speed up the pattern, moving it rearward, and it will slow it down, moving it outward or forward to the gun.
So moving it towards the shooter
speeds it up.
Show me what it does when it speeds it up.
Well, your barrel's whipping up and down.
Right.
And when you hang it out further, you're just slowing it down more. But when you move it rearward, you're speeding up the barrel.
Yeah, which is what Speedy showed on that.
Yeah, and so that's your basics on the movable weight and how that works.
Oh, I see what you're saying. Yeah.
So let's say you want it, you're here, but you want it to be here on the upside. Well, if you move your tuner towards the fast end of the bullets, you're speeding up the movement, okay? So let's say you put that movement here and speed it up by turning it rearward just a little bit, just a teeny weeny bit, and you put it on this hump. Well, now you're golden. You have no vertical, and you're in tune. But these are probably only 30 feet per second apart from going up to going down.
Okay.
And so next thing you know, you're in the middle of that, so you've got 15 feet per second. Next morning, it's colder. Everything slows down. Now your bullets have slowed down and put you right about here instead of being right here.
Right.
So what do?
You move it some more.
You slow down the tuner by moving it outward. And this puts the pattern back towards the slow end of the bullets. It moves the pattern this way when you slow it down. It moves the pattern this way when you speed it up relative to your bullet's exit. So ultimately, you've got 30 feet per second windows. You could go on over to this window by slowing it down, or you want to speed it up and put it up here, you could go over to this upswing. Doesn't matter which upswing you use, as long as you're on one of those upswings.
Right.
So you could go either way, and it could benefit you. But if you shoot a graph, you'll know exactly where it puts you on that graph.
Now, how far do you know? How do you know how far your valleys and your peaks are?
You do a graph, and you can actually measure it on the graph, on the target. Now, you can try to calculate the approximate angle.
Well, show me an example of how I would figure out.
Okay, if I shot a graph like this, well, let me start over. This one's getting kind of scribbled up.
Yeah.
Okay, let's say I shot a graph, and I started out here, and then you've got a gradual movement up here, and then it starts going back down here.
Right.
Now, you're probably not going to be shooting the slow end you're not going to be shooting 2,400 feet per second, but you're just doing downloading to see the window.
Right.
To see what's going on. Now, let's see. Ultimately, you're going to measure your amplitude from here to here.
Okay.
On the target. So you've got 1 inch of amplitude in 4 time windows. But yet from here to here is 2 inches in only 2 time windows.
I see.
So it's moving down much faster.
It accelerated. Yes.
So this gives you an idea of how fast your muzzle's moving, for one, and how much it's bending. Now, I wanted more amplitude. I wanted these suckers to end up here because I need a steeper upswing for further range, for extreme range.
All right.
I want them converging at a mile if I can get it there. I got close. But to do that, I actually put the barrel in the lathe, and I turned down my barrel 10 thousandths on each side.
Okay.
Trying to add flexibility.
Okay.
That helped. That got them up roughly 1/4 of an inch higher
Okay.
On that same chart. And I'm like, okay, I'm getting there, but now the barrel's getting too thin. It's getting kind of thin. I really don't want to go that much. So I realized it's also a matter of offset weight. So if you have twice the weight below the barrel, your stock, cheek piece, magazine, whatever, trigger, and bolt handle, which makes a difference as well. And then the weight above it is less than half of that. So you got 5 pounds below it, 2 pounds above it. You've got a little over that's roughly a 2.3 to 1 ratio. That's going to increase the bending because it's going to try to bow up in the middle because the stock's so heavy. It's trying to bend around your stock, okay? So what I did was add more weight in the stock to increase that offset. Well, I got more amplitude as a result of it, and I got the amplitude I wanted. We went to practice for the King of 2 Miles, and I was with a friend of mine that works for Barrett. And I said, buddy, can you do me a favor? Can you watch that rock and tell me if these 2 loads hit level? So I shot 2 powder charges, and they hit dead level, and it was 1680. So I got the convergence point out to 1680. That was the furthest distance I've ever done that.
How do you know which 2 powder charges to use?
Doesn't matter, just use the grain difference.
Oh, just the grain difference. Okay, so up or down?
If it's inside your calculated vertical, you know it's positive compensation. If it's outside of your calculated vertical, it's negative compensation.
So let's just say my load is, I don't know, 50, let's say 60 grains.
Okay.
Okay. It's not, just for everybody listening. So I can go I can go 59 or 61, assuming 61 doesn't throw me over the pressure. So it doesn't matter which way I go, as long as they're a grain apart.
And you got to go back to your graph and say, okay, what was happening at 61? Let's say 61 was this, and this is 59 here. Well, that puts you right at the top of where it reverses direction. That's not where you want to be. You want to be right in the middle of the movement. So you say, well, 59 or 61 was right in the middle of the movement. That's where you need to be.
Okay.
You see what I'm saying? So if you're testing it against another, in other words, with this graph here, 95 and 96 would be the ones to test. Sorry.
Yeah.
95 and 96 would be the ones that you would check it with.
Okay.
What would happen if you use 94 and 93? You know you're going to have a lot of vertical. The 93 is like a half an inch lower. See what I'm saying? So it depends on where you're at on the graph. And so that's why it's important to run a graph first. Say once your barrel's settled down, it seems to be shooting pretty good. You haven't adjusted the tuner yet, but it shoots pretty good. Run a graph to find out where your normal powder charge is. And that'll tell you where in the movement you are. And then change accordingly. Does that make sense? Now, if you're in negative compensation area here, well, the tuner will move you, say, up to here. Make the movement move this way. Slow the movement down. Put your exit time right over here.
Okay.
And try to get into that spot. And you'll see it on the target immediately. Your vertical goes away. You know, when you start coming up on this plateau and then the downswing or the upswing of the bullet, in this area right here is where you'll start seeing reduced vertical. And if you happen to see a slower bullet hit higher at 100 yards, don't worry about it. That's a good thing downrange. Now, it may hurt you at 100 yards, but it won't hurt you downrange. It'll do nothing but benefit you at all distances downrange, not just the convergence point. That's where the big misunderstanding comes in.
All right, so if I shoot this graph and then I change the tuner, it's going to look different?
It will move the pattern.
Okay.
To speed up the pattern, it'll move this way because this is the fast end of the bullets. This is the
speed
slow
up, that
end.
means move the tuner out.
To speed it up, no, you move it back.
Move it in, okay, towards the shooter.
Yeah.
To speed it up.
And you extend it outward to slow it down.
Okay.
Just like a fishing pole. If you extend it out further, it's going to slow it down more.
Okay.
If you pull it in, it's going to speed it up.
Yeah.
Same thing with a movable weight. And Now, as far as how much your adjustment affects it, in my experience, the weight behind the crown affects it a lot less. So you may have to turn it a quarter of a turn just to move halfway through the pattern. Mm-hmm. But if it was out at the end, you may only have to move it one increment to move it halfway through the pattern. So that's kind of up to you, but don't move it big. If you're in a good pattern, just move it a little bit and reshoot a pattern. Just find out where that particular pattern charge is now in that pattern. And you'll gain a quick idea of how much that tuner affects it. And if you're even producing a good usable pattern.
Right.
So, and a lot of guns, say a short-barreled 308 shooting a 120 grain bullet. It's possible for that bullet to exit before the vibration starts or before the bending starts. It'll always be bending, but it'll have really small micro up and down swings. And that's all you'll see on the target. Mm-hmm. That can happen. So don't be afraid to change bullets simply because of the exit timing's different. See if it produces a better pattern in that respect. Because I've always heard that 338 Lapua. Everybody tells me, man, the 250s really shoot good. Well, I want to use the 300. And everybody says, well, the 250s shoot better. Well, why is that? Well, it's because they're in a more advantageous spot of exit timing that the movement happens to be in. But the 300s, the movement's not quite as exciting, so to speak, as the 250s. And I found that out when I started shooting for cutting edge. I went through the whole myriad of weights for that particular caliber, for 338 and Shot Tech. And turns out the 254 was in a beautiful pattern. Loved it. Where basically the slower bullets were tracking up. And I'm like, you know what? I don't care if the BC's lower. That's what I'm going with, tune. And it worked out great. I mean, it absolutely shot phenomenal. And ended up winning first place at the world's longest shot with that. Exactly, that's how that happened. And everybody says, well, you're losing BC and you're losing that. I said, yeah, but I've still got consistency. Mm-hmm. And that's all I need. I need tune and consistency. And the 300s were exiting when the barrel was basically parallel. So you had no compensation. As long as your velocities are good, it's going to shoot good downrange. But if your velocities are crappy that particular day, which can happen,
right,
due to throat erosion or whatever, humidity or whatever causes to do that, then you can suck. And I don't want to take a chance on. So I already suck at reading wind enough. I don't need to have the tune biting me as well.
Yeah.
And so it just depends on the gun and the tuner and everything. And it's just totally different on every gun. So there's no way you're going to be able to build a universal tuner. I wish I could help you do that. But what I can do is give you an idea of to let the customers try this graph. And if it's a sawtooth pattern, which most likely it will be, they know the width of the tune is 50 feet per second or 30 or whatever. You know, you got to read the velocities on each shot. Attach the velocity to the shot, mm-hmm, and say, okay, this window, let's see, this window in particular is this wide. Mm-hmm. And so that's a pretty wide window. That's hard to get. That takes specialized weighting and stuff. But for this one, you've got a window of, maybe 100 feet per second wide. And you got an amplitude of 2 inches, roughly. So you know your amplitude, you know your width of window. So you can learn everything from this graph. And by spreading everything out so drastically, it's a lot easier to see. But if you're sitting there trying to shoot groups with exactly the same velocities, guess what? Your barrel's in the exact same position. So you're not actually seeing what the barrel's doing. You're just shooting groups, hoping for the best group you can get. And that's why you see a lot of people say, I didn't see a difference. And the other guy says, well, I saw a big difference. My groups went from an inch to half an inch or less. Mm-hmm. And for all he knows, that could be just pure luck. Your groups can change. If you're not changing nothing, the groups could change exactly the same way, depending on how you shot. Like you said, cold shooter, But, people that do this a lot, like you and me both, we know if the wind did it, we know if we twitched it, we know if the bags aren't, we know if it's not right. So it's more of an intuitive thing to know that, okay, I'm going to trust my intuition and say it wasn't me or the gun, it was just the wind. Or it wasn't the wind, it was the tune. Mm-hmm. But if you spread everything out to a different exit time, it's going to open up a whole new world as far as seeing what's happening with that barrel. And that's the only way I know to do it now. I mean, every gun I test, I'll be honest with you, I really don't even shoot groups much. I go right out there, right out of the gate and shoot a graph. Okay, it sucks. Okay, it's going down, tracking hard. Too much weight on there. I start trimming back the weight. Okay, this pattern looks nice. This pattern looks really good. We're going to go with it. It's not a wide pattern, but it's wide enough to where it's 100 feet per second, I'll take it. And then if I don't want to mess with the tuner anymore, I just simply pick the powder charge that's right in the middle of that and go with that powder charge from there on out. And what that means is if it were to change 50 feet per second, both directions, okay, you would still be in tune. Nothing will change. And ultimately, that's good enough for most guns out there. You're not going to see more of 100 feet per second change in velocity, or more than 50. Unless it's super cold and super warm, you might see, 30?
Right.
Maybe. So you're still in that window. The window's wide enough where you don't have to touch nothing anymore. Do not jack with that tuner if it's shooting good. If you start seeing vertical flyers big time, that's when you start questioning your tuner. You know what I'm saying? And so a friend of mine was shot at Kansas, and he basically got lucky, and he reached up there and just grabbed a tuner. He had horrible vertical, but this was at 2,600 yards too. So, and he had asked me the night before, hey, come over and give us a tuner class. So I said, okay. So everybody's already half drunk, and so I'm not sure what they remembered and what they didn't, but I'll say, look, I'll tell you this. If you see a lot of vertical, crank it big because it's behind the crown. And he said, what do you think? I said, at least 3/4 of a turn. If it's really bad. Now, if it's not, leave it alone. You're good. But if you've got horrible vertical, it's full out of tune, turn it big. Once you get it there, then you move it small to tweak it in. And don't do another big turn if it fixes it. He said, well, I may go full turn. I said, that's fine. What direction? Well, if it's like the sawtooth here, it doesn't matter which direction, as long as it puts you on the upswing of one of those humps.
Right.
And so he reached up there after the first target. He had horrible vertical. And he's just telling me about it afterward because he was just so excited and pumped that tuners worked.
Yeah.
He didn't have time to play with it much because he just got the barrel. He worked in his 100-yard loads and shot 6 shots at the match to confirm and then shot the match. So after the first target, he reaches up there and grabs it, does a full turn, gets back on the second target, and tore it up from there on out and won the match. And he jumps up and says, tuners work. And so, there's things that you'll see and things you won't see. And what we're trying to do is make it to where you can see this stuff. And shooting groups makes it tough sometimes, It really does. Guys that can't shoot tight groups, it makes it tough on them to see the differences of what the tuner's doing. And other times, you can see it. It just depends on what pattern you happen to be adjusting at the time. But if it's a flat pattern, you turn that tuner all day long and you're not going to see a heck of a lot. But if it's a sawtooth pattern, man, you turn that tuner just a little bit and it gets big and then it gets small, then it gets big and then it gets small again. So that's what I'm trying to enforce with all of you guys making tuners is check the pattern that you're adjusting. Otherwise, you're just randomly turning it till it shoots good. And that takes a lot of shots down the barrel, a lot of skill to know you can shoot good groups all of the time. And a lot of the new shooters grabbing tuners don't have that, and that makes it tough on them to get it right. And another thing is, like I told my buddy, I said, if you see a lot of vertical, no matter what anybody tells you, tuners affect just the vertical. Now, there's a lot of guys that don't believe that, and I understand that. I'm certainly not saying everybody's wrong. I'm just saying from my testing, using different velocities, let's say we go to a shooting tunnel. I went out to Gene Begg's place. We shot in the shooting tunnel, and I told Gene, shoot the gun. And he says, so what am I doing here? I said, you're going to shoot 2 different powder charges. Tell me what to do. Aim for the same spot, aim for the same spot. They hit straight up and down to each other. Didn't hit out to the side, it's straight up and down. So he says, well, okay, well, you hit an inch low. It was only 30 feet per second difference. Mm-hmm. I said, okay, give me the gun. I took it outside and I chopped off the end of that barrel on a chop saw, deburred it, brought the gun back in. He's looking at me like I'm nuts because this is an integrated tuner.
I'm looking at you like you're nuts right now.
Well, I can understand that. And, what it was is a recessed crown.
Okay,
on my 6-dasher. I wanted a solid tuner.
Okay.
No movable part. So I trimmed it, brought it back in there, gave it to him, and he says, oh, it's close now. It's only about a 1/4 inch low. So I said, okay. Went outside, covered up everything, stuff caught in the barrel, deburred it, brought it back in. He's already laughing at me by then. And he comes out all excited. And he says, I put them in the same hole. I said, were they straight up and down? All day, straight up and down, for the most part. Mm-hmm. It may be 1/8 of a bullet off to the side. I said, but straight up and down mostly. He goes, yeah. And so he goes, well, we're done, right? No. Oh, my God. I just shot a 0 group at 100 yards with it, and you're wanting to screw that up? I said, well, I want positive compensation for 1,000. I want it downrange. If there's a velocity variance, I can still do tight groups at 100 yards, but the velocities have to be level. Does that make sense?
Yeah.
So he just couldn't believe it. He was just like, I can't believe you're changing this. These 1,000-yard guys tune weird. And I said, no, it's just a little different. I want them hitting level at 1,000. So we need to see that bullet 36 feet per second slower hitting 0.700 higher. And he said, well, how do you know that? I said, because I've leveled them out at 1,000, then I come back to 100 to check it, ultimately.
Yeah.
I don't count on my math all the time on that. And so he's like, I can't believe you're changing this. So finally, we got the bullets to invert and got the slower ones hitting higher. And he looks at me and just sagged his head and says, it's hitting higher. And I said, Gene, you act depressed about it. And he goes, I don't get it. I said, well, we want him doing this same hole at 1,000. That's ultimately, because it's a singular distance. And I said, but I could still go to a 100-yard match and kick butt with it. And I did. I went to Denton and shot with, oh gosh, I forgot who all was there. All the guys that are usually there. And I ended up getting 3rd place. And it was tuned for 1,000. Mm-hmm. And they said, well, how's that possible? I said, level velocities. It'll shoot good at any distance with level velocities, regardless of how it's tuned. But what happens when the velocities do go haywire? What's that barrel going to do with it? That's what you're tuning. So you ultimately still want level velocities for wind drift alone. But if it's slower, you sure don't want it aiming it lower at any distance. You know? So that's what we're looking at with positive compensation. It helps you at all distances downrange. Even though it varies from gun to gun, it still helps you. And you want to make sure the barrel's not actually aiming a slower bullet lower, which can actually exacerbate the issue tenfold. So harmonics is actually a very large affecting factor, but everybody's using fat barrels and thinking, well, it doesn't. That's why I did that, to get rid of that bending. And I understand the theory, but it doesn't do that all the time. Even with the fattest of barrels, if there's an offset of weight of any kind of, say, 2-to-1 ratio or more, that barrel's going to bend no matter how thick it is. So you've always got a chance of it aiming a slower bullet lower. If you put the wrong suppressor on, one thing I've stressed to the military, how do you know what it's going to do? It depends on the weight of the suppressor, not necessarily the baffle design. It can make things 10 times worse, or it can make it better. And you've got to make sure that's the case. And, we gauge it with different velocities, and that gives us a baseline to go off of with the calculated vertical versus what you actually saw. And let's say at 1,000 yards, why don't you switch back to my paper here? At 1,000 yards, I used to graph these like this. I would shoot a particular velocity.
Mm-hmm.
And the next one, 1 grain of powder would actually hit bullet or so low at 1,000. So pretty much a level.
Uh-huh.
Now we go to the next powder charge. It hits 5 inches low. And then the next powder charge, even slower than that, starts hitting down here and slower than that. They said, well, not all velocities are hitting the same spot. Well, they're not going to, because you have to speed up the rate. The larger the variance, you have to speed the rate up more. You can't do that. The rate's fixed into your gun. So what this means is, okay, calculated drop, CD, and then actual drop, AD. Calculated drop for these two velocities was 3.6 inches. Actual, 1/4 inch. Okay, so we're well inside of the calculated vertical.
Okay.
Now I go to the next slower load. The CD's about 6.8 inches. But the actual is about 4. Okay, now we go down to here. This one's biggie. 23 inches. Calculated drop. Actual, 9 inches. So even though they're not hitting the same height, they're hitting way less than a normal gun would put them.
They're being compensated.
Correctly. So this is where everything's not going to hit the same height. All velocities aren't going to hit the same height at only one distance. They're all reduced at all distances. It just doesn't spread out as much, put it that way.
Yeah.
That's ultimately how it works. Now, let's say you're converged at 800 yards. Let's go to 400 yards. If you know they're converged at 800, what happens at 400?
That would be like the worst case scenario, wouldn't it?
Mm-hmm. Mm-hmm.
Wouldn't they be like spread out?
Yep. You know the slower bullet's going to hit higher.
Right.
It's going to be hitting higher.
Yeah.
The worst case scenario, let's say you use 50 or 60 feet per second to check it, is about 4 inches.
Okay.
It's going to get better from there on out. So, this will help you, meaning from there on out, it's not going to be MOA. It's not going to spread out MOA. It only spreads out MOA after the convergence point. So if you put that convergence point way down range, it's just now starting to spread out at that range versus right here at the gun. You don't want it spreading out from the gun because it's going to be really bad by the time it gets down there. The bullets will never see each other again if they hit low at 100 yards on the slower round. And that's what you don't want. You want to make sure they meet up happy family at the target, as you say. And the only way to do that physically is trace your trajectories from 100 on past that. If a bullet's slower and it hits an inch higher, they're going to come back together downrange somewhere.
Right.
And it's going to be reduced. That's all that matters. It's not the actual amount of reduction. It's just that the fact that it is reducing it that matters.
So once you have this load, then you can tune it further, right? I mean, I guess if I'm trying to use this in my system, I would start here to make sure that I am in the correct range, and then I can do my usual seating depth and tuner and all that to make them as small as possible.
Like I say, the seating depth doesn't fix the random dispersion. It can correct the velocity variance from exit timing changes, but it's not going to make the bullet stop wobbling. A tuner is just physically, I can't think of any mechanism that it would make the bullet stop wobbling. But seating depth can correct the wobble for sure. So a lot of guys say, well, I use seating depth to fix my tuner. Well, what they did, they changed seating depth and it made the velocities level. That's what seating depth can do. Mm-hmm. And of course, the gun's going to shoot better no matter what the tuner's set at when it's level velocities. But to see a movement, you have to create different exit times to be able to look in a window of this movement. You know what I'm saying? It's like having two boards next to each other and a car drives by. And the boards are only a foot apart. All you've got is this narrow view, and a car goes by, and the guy's flipping you off as he goes by. You can't tell what's happening, but you get it wide, and you can kind of look out, and you can see the guy standing up doing this. You know what's happening now as it goes by. You've got a wide enough window to discern what's happening and what movements are being done with that barrel. And that's the only way I could ever see how these barrels move, is to widen that window 250 feet per second. That is a huge window that you're looking into as something goes by.
Yeah.
And so that's the best way I could explain it. That's probably not the most professional way to explain it, but.
Well, I'm going to have to obviously try it, and I'm going to have to send you the charts and have you hopefully explain it a little bit better.
I'll be glad to come back down. I'll be glad to bring some guns down, and we'll shoot my guns with these actual patterns where you can see these patterns do exist.
Well, I'm going to shoot my guns, and then I'm going to send you the targets and have you look at them.
Okay. Now, if you get a chance, you might use two different guns. If you have a same weight tuner on two different guns, you'll see two different patterns.
Okay.
You know, so look on there to get an idea of, you know, what patterns is that weight generally producing. And see if we can find a happy median to where you're probably already there, but see if you can find a happy median to where the weights benefit the gun in a pattern that's a little wider than other patterns. You know, the patterns are always there. It's just a matter of some are narrower with a particular weight, some are wider with a particular weight. And hopefully, but it's really it's a coin toss. I wish I could tell you the exact way to get patterns on every gun with every exit timing, but it's about exit timing. You know, the bullets' weights are going to determine the exit timing and the speeds, and they can vary huge, anywhere from 1.1 milliseconds to 1.8 milliseconds on the larger Shytex. And Hellfires, the 416 Barretts, they're around 1.8 milliseconds. And while our guns, 30 cals, 6 millimeter, they'll be around 1.4, 1.3 milliseconds. To give you an idea, my 22-250 pushing the 40 grains 4,000 feet per second is 1.150 milliseconds. So that gives you an idea of the range of exit timing, and the weights vary all the way up to 20 ounces between. And it's just, you've got to have a huge number of data points to start seeing what weight goes with what.
Yeah.
And so it's
all right. So testing, I need to do testing.
Okay.
I just want to see if I can repeat, or the point is I'm going to do these things. I'll send them to you. You tell me if I'm.
Okay.
Now, I the beauty is I have a gun that is obviously, I know it has a good tune. Already? Yeah. Well, I mean, I've been doing really good with it. So I know that
would be the one to see the graph.
So I'll start with that, and then I'll start with some of the new ones.
And note where in the movement your regular charge, charge is at. Now, one thing to keep in mind, when you're shooting a graph, don't shoot in a head or tailwind. Anything that's going to give you vertical dispersion. So try to shoot in a crosswind.
Okay. Or no wind, right?
Yeah. And try not to let the barrel get too hot.
Okay.
If the barrel gets too hot, the patterns will change. And now this is 150 degrees though. That's hot enough to cook an egg on.
Yeah.
And with my suppressor, the barrel gets hot quick.
Yeah.
Usually about 20 rounds, and that barrel's cooking with the suppressor on there.
Okay.
So try to keep your temperatures around 110, 120 degrees at most at the chamber on your gun, which shouldn't be a problem. That's probably shoot some siders, maybe shoot a couple of groups, make sure the gun's shooting good, and then shoot a graph. Probably 15, 18 rounds before it starts cooking over 120 degrees, because it will flatten out, because the barrel actually gets rubbery and stops whipping as much when it gets really hot, because it's weakening the metal.
Yeah.
And so a lot of people don't realize that your gun could be in tune cold, But when you get up to 20 rounds and it's cooking out in the sun, some of that tune can go away. So that's one thing that you might be seeing too. Not to mention, you'll get velocity spikes because the heat in the barrel itself.
Yeah.
So there's a lot of things that happen. So try to control that heat somewhat. Keep it around 110, 120 degrees, and then let it cool if you have to.
All right, man.
Well, repeat.
That's a lot. That's a lot to take in right there.
I know. And I'll be glad to come by and reiterate on anything that anybody has any questions with. And I'll be glad to bring some of my guns to demonstrate some of the different patterns that it produces with different weighting and so forth. Any way I can help. All
right, man. Good deal. Thanks for driving down here, and
You're most welcome.
I'll do some testing.
Awesome.
Thank you. Take care.
Okay.
Bye-bye.